Okay. All right, percentile. Okay. Percentile is not to be confused with percent. It seems a little bit blurry. I just want to make sure that's clear. Okay, is a term used to indicate position. What statistic have we discussed that is a measurement of position? Yeah? Median, right? Median is a measurement, is a statistic that measures position because it tells you 50% are below and 50% are above, just like that. It is a comparison score. For example, if your average is in the 77th percentile, then 77% of the students scored lower than you, and 33% of the students scored above you. It's not an exact measurement, it's approximate, okay? It's, remember, more often than not, statistics is not an exact science. Okay, if you got the top average in your school, your average would be in the 99th percentile, meaning 99% of the students scored below you. Percentiles are numerical values that divide the order of a data set into, they divide an ordered data set, notice ordered from lowest to highest, into 100 groups of values with at most 1% of the data values in each group. When we discuss percentiles, we generally talk about the kth percentile. The kth percentile for an ordered list of data is a numerical pk such that at most k% are smaller than pk and 100 minus k% of the data are larger than pk. So here's the calculation we use. K equals the number of values below x plus 0.5 times the number of values that equal x divided by the number of values in the data set times 100. Oh my God. I'll be right back. Hold it. Okay, here we go. Okay, so let's do an example. First of all, we have to put this in order. I will read it and you write, okay? So I don't want you to have to look up and down all the time. Are you ready? Just write it in here. 59, 72, 77, 86, 96, 98, 103, 108, 1112, 116, 116, 119, 122, 125, 132, 134, 146. Does anybody need me to read them again? Okay, there they are right there. So calculate the percentile rank of a score of 116, round to the nearest unit. So K equals number of values below X plus 0.5 times the number of values that equal X all over total number of values times 100. and all of this times 100, so we get a percentile. So we can calculate it. K equals, well, let's see. Calculate the percentile rank of a score of 116. Notice there's 116 right there. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values below 116 plus 0.5 times 2 values that equal 116 divided by 17 times 100, and this is equal to 59. Okay? So, what can we say? The 59th percentile is equal to 116, and all it's telling us is 59% of the values are below, spelt that wrong, are below 116. Okay, can I explain anything better? Just use this formula. There's different ways of calculating it out there, but use this one. Again, it's not an exact science, so even to the answers to some of the homework questions, like for tonight for homework, you'll be able to do the rest of all this. So you'll be able to do this, you'll be able to do this, and just you'll be able to do the rest of it. Okay, that's your homework. It's on the previous page. Okay, what if we want to go the other way around? Right? What if we want to find the data? Here they gave us 116 and we calculated the percentage below. What if they give us the percentage below, and what value is it? So we're working the other way around. Arrange the data in order from smallest to largest. Compute the position C of the percentile using this formula, where n is the sample size, k is the required percentile. Now there's two rules. If C is not a whole number, round up to the next whole number. Locate this position in the ordered set. Remember, this is a position, it's not your value. Right? It's a position. Once you get the position, then you have to find the value. If C is a whole number, find the average of the values in the C and C plus 1 position in the ordered set. The average value will be the required percentile. So, what is this saying? If C is not a whole number, then round up. So, for example, if C is 2.01, even though it's only 2.01, then go to the third position. Right? If C is equal to 2, then you're going to have to find the average of C plus 1 position. So let's do some examples of that. Alright, so the first thing we have to do is put them in order. So I'll read you right. Ready? Just so you don't have to save looking up and down. 10, 12, 15, 16, 17, 19, 19, 22, 23, 27, 30, 30, 32, 33, 37, 48, 49. Okay. which of these numbers correspond to the 65th percentile, or which of these numbers is such that which number is such that 65% of the values are below it? Okay, let's take a look. So we go through our formula, NK over 100. Now there are 17 countries. They want the 65th percentile divided by 100, and that is equal to 11.05. So notice it is not a whole number, therefore round up to 12. It is not a whole number, therefore round up to 12. Okay? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's our number there. The 65th percentile occurs at the 30th position, at the 12th position. So P65 is equal to 30. 65% of the values are below 30. Okay, let's do example 3. Find the 25th percentile for the following. Okay, so I'll read you right. Ready? 2, 6, 8. Is there 3? Yeah. 10, 10, 10, 11, 11, 12, 12, 13, 13, 13. 14, 16, 18. Find the 25th percentile for the following data set. Okay, so we go C equals NK over 100, and that equals, how many values do we have? 16 times 25 over 100, that equals 4. So what we're going to have to do now, because since it is a whole number, since it's a whole number, take the average of the 4th and 5th position. Take average of 4th and 5th positions. 1, 2, 3. One, two, three, four, 4th and 5th position. There's the 4th and 5th. So just P25 is equal to 10 plus 10 divided by 2, which is 10. 25% of the values are below 10. Okay, so that's pretty much sums up percentiles. Now, instead of dividing your data up into groups of 100, you can divide your data up into groups of 4. This is where the quartile comes in. Quartile 1 equals the 25th percentile. 25% of the data lie below Q1, or the lower quartile. Q1 is the median of the values below the median. Second quartile is P50, which is equal to the median. 50% of the data lie below Q2. Q3, the upper or third quartile, 75% of the data lie below Q3. Q3 is the median of the values above the median. Okay, what I want to emphasize here, even though Q1 is the 25th percentile, Q2 is the 50th, Q3 is the 75th, never use percentile formulas to find quartiles. Never use percentile formula to find quartile. The reason is the percentile formula is not accurate. We want accurate quartiles. Okay? So the box plot is, we're going to illustrate, the box plot is a 5-number summary. Looks like this. Some people call it a box and whisker plot. It can look something like this. Okay? Tells you how your data is distributed. This is a scale. So notice it's a 5-number summary. This number, this number, this number, this number, and this number. So this is your lowest value. Usually this is your minimum value. This one is your max value. This is your Q1. This is Q2, or your median, and this is Q3. Now in a modified box and whisker plot, which that's what I'll ask you to draw on the test, we show outliers. Okay? So they'll show outliers here, so therefore your max will be an outlier. It won't end up there. Okay? And always remember to label. So I want to just show you how to draw a box and whisker plot using the formulas for quartiles. Procedure first we're going to check for outliers, because now we have a mathematical calculation to check for outliers. Arrange the data in order from smallest to largest. Determine the first and second quartile, or actually you should determine P. This is a little bit out of order. Determine Q2 first, and then it's easy to find Q1 and Q3. We're going to use Q2 to find Q1 and Q3. You can find the interquartile range. Compute. This is the calculations we use. Q1 minus 1.5 times the interquartile range. If there's any values below this computated value, you have lower outliers. If there's any values above this computed little calculation here, you have upper lie. Or I guess it's described here. So let's do it. I think everything makes sense when you have a good example. So I want you to leave some room here. We're going to draw, this is the scale for our box and whisker. So let's just leave some room here. Just leave some room here so you can draw your box and whisker, okay? Bring a ruler to your first test, which is October the 4th. because you'll need to draw some things. Okay, let's put this data in order. The data below represents top 20 countries with total Olympic medals. United States has 103. This was 2004 was the Athens Olympic Games. There are 19 countries. So, oh yeah, so it's United States. There's actually 20 countries in total, okay? There's United States is an outlier, and the rest, there's 19 other countries. So let's actually calculate these outliers and see what we have. I'm going to read it off. You write and I'll read so you can have it in alphabetical order. 12, not in alphabetical order, but in order from lowest to highest. 12, 12, 15, 17, 19, 19, 22, 23, 27, 30, 30. Yes? Sorry? Just stick a little 16 in there. So I'm going to read from the beginning. 12, 12, 15, 16, 17, 19, 19, 22, 23, 27, 30, 30. Thank you for correcting me. I appreciate it. Okay, after 30 there's 32, 33, 37, 48, 49, 63, 92, 103. Okay. Let's see what we can do here. So we need to find Q2 or the median. That's our, so the Q2 position is equal to n plus 1 divided by 2. 20 plus 1 divided by 2 is 10.5. So if we were to count, we're going to have to take the average of the 10th and 11th position. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need the average of the 10th and 11th position. Q2 equals 27 plus 30 divided by 2, and that is equal to 28.5. So that I think you're used to. Let's calculate Q1. Q1 is the median of the values below 28.5. So let's go Q1 position. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values below. Is going to be 10 plus 1 divided by 2 is equal to 5.5. So we want the average of the 5th and 6th position. 1, 2, 3, 4, 5, 5 and 6. Q1 is equal to 17 plus 19 divided by 2, and that equals 18. Now Q2, Q3 is the median of the positions above the median. I'm recording right now. Okay, thank you. So Q, we'll talk later. Q3 is the median of the values above the median. So we want it, again, it's the 5th position above the median. 1, 2, 3, 4, 5, right there. So we go Q3 equals 37 plus 48 divided by 2 equals 42.5. Now we have everything we need to check for outliers, so we'll do that. Can I explain anything better here? So we're going to check for lower outliers. Okay, so we're going to go, first thing we need to do is calculate the interquartile range. That equals Q3 minus Q1, and that is 42.5 minus 18, and that is equal to 24.5. So now we're going to go Q1 minus 1.5 times the interquartile range. Is equal, Q1 is 18 minus 1.5 times 24.5 is equal to negative 18.75. Are there any values below negative 18.75? No. So there are no lower outliers. Now let's check for upper outliers. So Q3 plus 1.5, my pen's dying, plus 1.5 times IQR is equal to, Q3 is 42.5 plus 1.5 times the interquartile range, which is 24.5, and if you calculate that, you're going to get 79.25. Do we have any values greater than 79.25? Yeah. Yeah, here we have it right there. Therefore, two upper outliers. 92, 93. Just try to leave room for your box and whisker. So now let's graph it. Oh, it should be 103. You're right. Thank you. So a lot of calculations. So we're ready to draw our modified box and whisker plot. We want to show outliers. So we'll call this number of metals. We'll start at 0. We'll go up by 10, I guess. We need a scale. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. We didn't have to go up to 130, but... Now, let's plot our outliers. So we draw the box and whisker above the scale. So, and similarly with the data points. So why don't we start? Our lowest value is 12. We'll put it right there. Our outliers are 92 and 103. What's the next value below our outliers? 63. So draw a dot at 63. Okay. Now, the quartiles form our box. So Q2 is 28.5, which is approximately there. Q1 is 18. And Q3 is 42.5. So there's our box. There's our whisker. And there you have it. So this here is your interquartile range. 50% of the data lie here. And another way of looking at it is 25% are below Q1, 25% are between Q1 and Q2, 25% are between Q2 and Q3, and then 25% are all the way up there, right? All the way up there, all the way to the end is 25%. So this gives you an idea of where just gives you a picture. Majority of the data lie in this area. There are your outliers. It just gives you a picture of your data set. From lowest value to highest, your outliers. Let's do another measure of position, and that's the Z-score. Okay. The Z-score for a data value is the number of standard deviations a value is from the mean. For example, a Z-score of 16 means the data value is 1.6 times the standard deviation above the mean. Minus 2.1 means it's 2.1 standard deviations below the mean. Notice, these are population symbols. So notice, if you take a value, subtract the mean, divide it by the standard deviation, you get how many standard deviations a value is away from the mean. So the formula you'll be using is this one. X bar is the mean of the sample, S is the standard deviation, and X is the value you want to calculate a Z-score for. So let's do that. In Kelly's English class, the mark for 39 students have a normal distribution with the mean of 67% and a standard deviation of 11.5. Kelly has a mark of 71%. What is Kelly's Z-score? So you go Z equals X minus X bar over S. So her score is 71 minus the mean of 67 divided by the standard deviation is equal to positive 0.35. So that's her Z-score. So she's not too much above the mean. She's only 0.35 of a standard deviation above the mean. Kelly's score of 71 is 0.35 of it's not even a full standard deviation above the mean, of a standard deviation above the mean. Good? This here, ignore. We will study this in the normal distribution. To be studied in Unit 5. This is not on your first test, no. We will do that in Unit 5.